Nano fam, it's Tuesday evening. It's time to work a bit on RS Nano to bring a little bit more of Nano to Rust. Welcome. Welcome to this weekly stream. Let's see, everything is online. Yeah. So today I tried, I'm using a cable, not the Wi-Fi, because I had so many frame drops last time. So I actually used the cable and this looks much better now. So, hello, welcome, everybody. Nano is the light. Twitch works, looks good, says Undefnal. Great. So, you guys, you know the game. Post your Nano addresses in chat, and I will send out nanos from time to time. I was on the Nano Community Initiatives podcast from Carlos Murgas, and on last Saturday, have you guys tuned in? I was a bit excited because I don't actually like public speaking, but that was really nice hearing the stories from Diva's Kitchen. And if not says, nope, I was dead. You were dead? Why were you dead? Okay, we have the first Nano addresses coming in. Let's just copy them. And let's put them to a new file. This is text. We have this one. The first one is from Sammy. And the next one is from Anderson. Copy that. And oop, wrong file. Yep, and then we have yeah, good. So I have good news. So the last stream was a bit boring because I was looking for a bug and I just had no idea what was going on. Couldn't find anything, and I was just very confused about the behavior. And I found out what the problem was, and the problem was just something completely different that I thought of. So let's go back to I redrew the diagram so that we can yeah. Oh, I did not want to close one. I redrew the diagram so that we can discuss what was the problem last time. Oh, Undefnal, have I copied your address? Not yet, I don't think so. Let's just add that to Undefnal. Okay. Yeah, and so chat, if you don't know how to get a Nano address, if you are on the PC, then just go to nalt.cc. This is a web wallet. You can get a Nano address there. Or if you are on mobile, download the Nautilus app and you can get a Nano address there. Okay, so yeah, let's just discuss what went wrong last time. And this is actually a very interesting thing, and it made me like almost cry because it was okay. Let's start at the beginning. So I had a misunderstanding of how the unit tests work in C++. In C++, let's get back to what I was working on. So I was working on switching the async runtime from Boost to Rust plus Tokyo, and I have two separate implementations now. So I introduced an interface. This one here, TCP socket facade. Can we make it a little bit bigger maybe? And this interface, I introduced it to encapsulate all of the access to the async runtimes. And the red boxes are the C++ boost async runtime, which is still the default runtime in RS Nano. And then I started a new implementation which would use the Rust Tokyo runtime. And I tried my best to make it behave the same as the boost runtime. And then many tests failed. And I had no idea why. And now it comes. This was the problem. I thought that when a unit test started a node, that it would also start the async runtime, that it would run the event loop, and it would poll what like actions what it has to execute, like network calls, reads and writes, and background tasks. And I thought, yeah, just if the unit test would start a node, that it would also start the async runtime, and that assumption was wrong. That assumption was wrong. In the unit tests, if you start a node, it does create a boost async runtime, but it does never execute it. And the tests, they manually trigger the event loop, and I can show you this in the code even. Let's go to the test. Let's just go to which test could we go to? Active transactions. So these are the unit tests. And when we look at the test, it has these calls to assert timely. And can you see it? Yeah, assert timely. And what it does, or what I thought it does, is it has a condition that it checks, and it has a timeout. In this case, 5 seconds. So it has a timeout of 5 seconds for this condition here to become true. And my false understanding was that it would just periodically poll and or periodically check this condition. But what it actually does, if we go to this macro, is it actually calls system.poll, which triggers the async runtime. And so the tests would not execute any async reads or any async writes until we call an assert timely or another macro that triggers the system poll. And that was my misunderstanding, and that was why the test behaved so wildly differently. And when I found out about this, I was devastated, because I thought I could never make Tokyo behave like that. And now I would have to rewrite all of the unit tests to not trigger the async runtime manually. And I thought this would be a task way too big. Like, this would take forever to do. And I had no idea what to do. So I just thought I would, try to make the tests run without changing them. Or maybe just to see if the tests were maybe not so reliant on the async runtime as I thought. And the good news now is the tests are not. So I found a couple of small bugs in my adapter layer, or in my async emulation, and the tests pass. And I just had to change like 5 tests, and all of the other tests, they just run. So let me show you. Let's go to a terminal, and so we can run the unit tests just by executing a core test, and this is using the boost runtime. And as you can see, the tests they pass. I won't let them all run, it takes long. And now let me run the test with the Tokyo runtime. With an environment variable, nano enable Tokyo. And let's start the test. And now you see there's even like a small log message, Tokyo is enabled. I added that for myself so that I can see whether Tokyo is active or not. And as you can see, the tests, they are green. And almost all of the tests are green, like 2 or 3 are failing, and of those I know why they are failing, and that is not a big issue, and I have it on my list to fix them, but it's just not important really. It's those tests are, I have to basically rewrite them because they assume that you poll the async runtime manually, and yeah, I will fix them. Maybe next week. That is not like really important. So LFLF says, congrats on the fix. That must have sucked to figure out. Oh, it did. I was devastated. I thought I had to rewrite all of the tests. And if not, says damn sorcery. Yeah, I'm really excited about this because switching out the async runtime is a huge change, and that was the change I was most afraid of. And I think if I can get this to flawlessly work now, that what is the most or the hardest thing I did in bringing Nano to Rust, and I was the most afraid of from this change. LFLF says, really like the new chat notifications, by the way. Nice setup. I thought I need more space, so I removed the sidebar. Okay, let's abort the tests. So the tests run, and I was really excited about this. And then I thought, okay, the tests are green. Let's see what happens if I run the Nano node with Tokyo. And there I encountered a bug, and I have not found the reason for this bug yet. And don't worry, I won't search for the bug on stream again. No frame drops today, says Sammy. Yeah, that's because I'm using a cable today, no Wi-Fi. Yeah, so when I start a node, so let's start the node. Nano node with network beta and daemon. So it does its thing. It starts up, and oh, let's also, I have a Grafana instance running where we can see what's going on in the node. But for that, I have to start the Prometheus exporter. So now we should see, yeah, so this is the node running. As you can see, it's confirming. It's running pretty slow because it's a debug build. And as you can see here in the Grafana dashboard, the spike, the green line going up here, these are the confirmations. So it's just confirming blocks. It's bootstrapping the beta ledger. And it works well. And let's now stop the node and let's run it with Tokyo. So Nano, enable Tokyo, and let's start it up. And the exciting thing here is it does its thing. It connects to other nodes. It even confirms a couple of blocks. Where, oh, it doesn't. Yeah, you can see there was one log. Maybe you didn't see it. There are some log messages which say cemented one block, but it just doesn't cement a lot. So it's just a couple of blocks, and it seems to get stuck. And even here in the graph, so the spike upwards was running it with the boost async runtime. And okay, so this second spike, can we make this graph bigger? Can we? I think we can maximize this, can't we? View? Yeah. And maybe... Okay, now my camera picture is in the way. Let's minimize. And let's move this bit to the side. So the first green spike was running it with boost, and the second green spike is now running it with Tokyo. And as you can see, it initially confirms some blocks and then it just stalls. And this is the next thing that I need to figure out. And my guess is that it's not something big, because all of the unit tests are green. And that means it can't be like a huge bug. Maybe just a timing issue with the new runtime. I don't know. So this is my goal, to find the reason for this bug. And then I can start like removing the old async runtime, and then I can make it maybe more Rust idiomatic, because currently it uses the same callback style async patterns that the Boost does, and Rust has a much better async implementation, where there is an async keyword and we don't need to use callbacks, and we don't even need to do heap allocations. So, oh, what's that? Something is going up here. The count. What is count? Cemented. The block count. Yeah, not much going on, and I need to find this next week. Undefnal says finding a timing issue in async whatever seems like fun. Yeah, no, yeah, this is, yeah. Guess what? Guess how I'm going to approach that one. I'm going to approach it with my stupid print line debugging. Except you guys maybe have better ideas. Although Tokyo has really nice debugging tools, but I have not used them yet. Okay, so let's stop the node. Let's stop the node again. And yeah, but it's still cementing. Very, very slowly, but it still does something. You know, guys, this is strange, because I tried this out before I started the stream and it would completely stall. But this does not look like it's stalling. What I find strange here is all of the log messages with process 0 elections, because it should process elections. So that looks strange. But yeah, I'm not going to torture you with another stream where I debug. So let's stop the node. And yeah, my idea for today was, because I get this question from time to time, the question is, how do I keep up with the original Nano project and the changes there? And I was a bit lazy with that. And if you go to the RS Nano GitHub, it says it is 21 commits behind. So I thought, why not show how I keep up with upstream? And I thought I would just merge a couple of commits here, maybe not all 21, but just to show how I keep up with upstream. And we could then even like discuss what these commits are doing and learn what's currently going on in the node development. What do you guys think? LFLF says, maybe you just have to stream to run the RS node. Yet that is, I haven't thought about that. Maybe it is the stream. Yeah, but I'm sure it's something small. All tests pass. If all tests pass, it must be something small. Okay. Yeah, so let's pull the upstream commits. Let's fetch the upstream commits. Git fetch upstream. And the way I do this is I merge each commit individually, because then I can be sure that first of all that I get all of the changes, or I watch or I see all of the changes, and usually I get so many merge conflicts that going one by one, it makes it easier, and I can commit or every merge and yeah, that's just like small steps again. So this is software development from my point of view is all about going in small steps, and that keeps you out of trouble. So let's see. So 21 commits behind. And these are the 21 commits I'm behind. And the first commit I'm behind here is this one from Colin. And it says, let's open it up. This commit says, this delays obtaining a sample from steady clock unless it is configured to be needed. Excessive sampling of the steady clock has an impact on node performance, so should only be done when needed. So first of all, I am super happy that Colin or the Nano team that they write meaningful commit messages. So I know about this one. So the Nano team did a bit of performance profiling with FlameGraph, and they found that there was a place in the code that would degrade node performance, and that was the stats. So the stats are just counters, and we use those counters to debug the node, to measure its performance, to monitor the node, and these stats are not enabled by default, I think. And what this commit does is it does not get the current time from the system clock unless you enable the stats. And the old behavior was to always get the time, and this would hurt performance. So we just have to introduce the same change here in RS Nano. And this we can't automatically merge this one because stats is already completely in Rust. So all of these code changes here in C++, the file doesn't even exist anymore. Or maybe it does still exist, but all of that code is gone already. So we have to bring this change over manually. So let's see, what does it do? So this is the place where it gets the duration. And and this if here is the font size too small? Can you see it? And this change, this if statement here looks like it is new. If has interval counter or has sampling. And these are helper functions. And then it does get the current steady clock time after or inside the if. And we have to do the same thing. So let's see how our code looks like. So let's go to stats RS. And here we are, stats RS. And where is this? Which function is this? Update. It is the update function. Okay. And we do the same thing. We just do an instant now at the beginning. And I think we should also guard this with an if clause and do an early return if it is not enabled. So it does two checks. It checks whether in config sampling enabled, and the second check is config lock interval counters. And in our code, where do we, so here's the if for the lock interval counters. And where is the check for the sampling enabled? Down there, sampling enabled. Has interval counter, has sampling enabled. And sample interval is bigger than 0. So I want to keep it very close to the C++ version. So there are those two helper functions, has interval counter and has sampling. So let's just introduce them here as private functions. So has interval counters. That was name, yeah? No, counter. And it returns log interval counters is bigger than 0. So it returns bool, and this returns config log interval counters bigger than 0. And the second function has sampling. Let's copy that. So has sampling, and has sampling checks for sampling enabled and sample interval bigger than 0. So config sampling enabled and config sample. What? Oh, entry. Entry. So this takes an entry. What is the entry? This is the entry. Yeah, let's just pass the entry into our function. What is the entry? It's a stat entry. So let's say entry. And what's the condition? Sample interval is bigger than 0. Okay, so we brought these two helper functions, and let's see what the code does then. So we have these two, and the very first thing it does is now can we expand here? I want to see the full code. So this is inside the if not stopped. Can we expand this even more? So this is the update function. And we if not stopped, we have the if not stopped. Yeah, here we have the if not stopped. And inside the if not stopped, we ask duration. Yeah, so we do the entry counter add value, and we notify the observers. So I think this is being done in here. No. Oh. This adds the value if timestamp. Counter add. Where's the observer notification? And this is where we access the clock. Can we just early return here? Because there's this. Can we just? I have a trouble with this split view. Can we just view the file? How it looks? Here. JSON. Which line was it? Here. So there's this if not stop, then we have here the if, where it does the check for the sampling enabled and the counter, and Yeah, so we could do an early. I'm a fan of early returns because I don't like deep nesting. So let's just early return if doesn't have an interval counter and it doesn't have sampling. And we do this after counter.add and count observers. Okay, so we do this here. So if not has sampling, it has interval counter, and not has sampling, and the entry. Oh, the entry's destroyed. So we have to move this line inside of this block. We just return here. And we have to return a result. And I think we have to return OK. Because let's just go to the bottom. Yeah, we return OK there. Anyway, so early return. And then we can move the now, the instant now, down there. Right? Right. Okay. I'm just wondering where is the node the observers? Because on the Rust code there's this count observers notify. Why don't we have that in Rust? Why don't we have the count observers here in Rust? But the unit tests, they would fail if there was something missing, I would guess. Oh no, I remember. Oh, this was a long time ago. I think the count observers were not used in the node itself, but they were just being used in the GUI. There's a Qt wallet. Was it the Qt wallet? I remember it was a long time ago, and the observers were not being used anywhere of interest, so I removed them completely. Yeah. Okay, so we have the early return. Now let's see what the other changes. Which here. So we moved the instant now down there. And okay, it uses the helper functions here instead of going directly to the config file. Sample start time. I have to make this a bit smaller because I'm getting confused by the line breaks. I'm sorry, chat. Can I disable the line breaks? No. S interval counter. A lot of things changed here. Lock counters impl. Is this new? Lock count? What is lock counters impl? Block counters. And what is this hash sampling? So is this... Ah, okay, so there... Now I get it. So this part down here is the same as this part up here. And lock counter symbol is there already, yeah. And it does... Okay, so let's also use our helper function here. Lock interval counters. So if self has interval counter and then it does this thing. The rest looks the same. And in the samples down there, it just has sampling. So here we say if self has sampling, and we need to pass the entry. So I like that. So just making, let's go back to, this is how it was before. That if statement is not like the simplest one, because you have to read the sampling enable, then you have to read the sample interval, and replacing this by if self has sampling, that's just simpler, easier to understand. I'm a fan of those small refactorings which make the code easier to read. So that looks good. Has sampling, and in down there it does the lock samples impl. Where is the lock samples impl here? Down there. Where's the has samples here? Okay, push back. Yeah, I think that is this change. So let's compile. First of all, let's reformat the code. And let's compile the tests. And then I'm just going to run the stats tests. Or no, let me show you how the gtest parallel tool works, because we can run all of the tests in parallel, and then they run really fast. And Piotr did a lot of work to enable that. %. Yep, so while we compile, let's give away 1 nano. So chat, if you still haven't posted your address yet, post your address and you can get a nano. So while this compiles, let's open up our addresses. And we have 1, 2, 3, 4 addresses. And let's pick a random number. Between 1 and 4. Let's go. The number is 1. So Sammy, congratulations. Let's copy this. And let's go to Nalt. Send. Is this the correct one? PU? Yeah. 1 nano. Confirm and send. Unlock the wallet. There you go. Congrats, Sammy. Okay, let's see how far is the compilation. Still not done, 96%. So I think this was everything that we needed to do for this commit. Let's just quickly have a glance again. Yeah, this looks... This looks good. And... Oh... Stupid me. I haven't merged in a long time, so I did it wrong. I made the changes directly, but I have to trigger the merge first. So let's just stash our changes. I have to merge it first, and then when I get the conflicts, then I have to resolve the conflicts. So, come on. Let's have a look at the changes. So, oh, those are changes I made before the stream. Haven't I committed them yet? Oh, okay. You know, chat, then here's what I'm... Ah, this is bad. Okay. Let's first commit the changes that I made before I started the stream. That is those. And that is in the Rust node. Trans socket, yeah. Source. Rust node, source, transport. Yeah. So let's commit that first. Fix failing unit tests. Tokyo. And then what else do we have left? Just the change in stats. Yeah. So now let's stash those changes. And let's merge. Let's merge this commit. Where's the commit ID here? This one. Oh, it did not copy. Paste. No. Let's copy it from here. Okay, and because this, yeah, see, this is what I usually get now when I merge changes. I get conflicts, and when I look at the conflicts, both modified, yeah, in the stats, the CPP, but I won't, oh, can we just resolve it with powers? Can we, yeah, okay, I'll just remove it by hand. I think there's a quick way to do this. Stats CP. And yeah, I'm just removing everything that upstream did here. And just keeping my changes. And if I do a diff now, what does it say? Yeah, nothing changed. But now can I do a git stash apply? Oh, I can't. Oh, that's... Why can't I just apply in the middle of a merge? Is that not possible? Where the needs merge. Git add nano lib. Oh, this worked. Okay. Yeah, this worked. Okay, so let's commit. And that was it. Just making the core tests again. I want to run them. But yeah, so chat, this is how I do it. So the next step would be now to go to the next commit. That isn't merged yet. And that is this one. Only update timestamp when sampling is enabled. Let's have a look. So what does it do? It moves this one to down there. How does that help? I think this is just a cosmetic change, so that we have the helper functions on top and then we have the logic down there, because there's no change in the logic, is there? Oh, there's one. Counter add value has sampling, only update. Only update timestamp when sampling is enabled, as it has performance impact. Okay, so this has changed here. This line. This is new. And this comment is new. Okay. So the tests were built. Let's run them. And I have gtest. Is it? No, it's not in there. I have gtest parallel installed. And you can just give it the name of your test file, and then it runs them all in parallel, and it goes super fast. And it has some issues by going so fast, so there are tests here that fail, that would not fail if you would run them sequentially. But that's okay, so to get a quick idea of whether I broke something, it's okay. Yeah, you can see them running here. So this looks good, so let me go to, while those tests run, let me go to the next commit here, and let's also merge that one. So the commit ID is this here, copy that. And let's say git merge. There is, I can give the merge strategy with ours and theirs. Never done this. Let's see how I can. Here, dash as ours. Let's try. Git merge that as ours, and let's give the commit ID. Oh no, it should not commit. That's abort. Can we say no commit? No. Oh, I'm still in the merge. What? Oh, I think I made. Let's have a look in the graphical Git client. That always helps. Did I not add the Rust files? in my last merge commit? Oh, I didn't. Oh, that's bad. Yeah, but it doesn't matter. Let's just add them now. Add Rust. If I amend, do you know, will it destroy the merge info? Oh, there's something new in chat. Monica James says, hey, what's up? Hey, welcome. Welcome to this development stream. We are working on RS Nano, the Rust port of the Nano cryptocurrency node. Can I amend? LF is amend should work, I think. Okay, let's try. Cannot amend. Oh, I'm in the. Let's abort the merge. So I was in the new merge. Oop. What? Oh no! Is it gone? Oh shit! Oh no! This is. I've never had problems with merging, never. And I stream it and I fuck it up. Really? Yeah, I did. Oh no, it's not gone. Here it is. It's still there. Okay. So let's hit stash apply again. Okay, now let's add that. And let's amend. Isn't Git fun? It usually is not. So I usually don't have problems with Git. So let's amend. Okay. 5x is here again. Hey, hey. So, yeah, to the new guys, post your nano addresses in chat, and with a bit of luck, you can get 1 nano. Okay. I think now it's okay. Let's just quickly check again. So we have the stats change in our merge commit. No, here, this is the merge commit, yeah. Okay, so now we can go to the next one. And the next one is this one. So let's copy that commit ID again. Let's see git merge. Pasting that commit ID. And we have conflicts. Oh no, abort. I wanted to try out the merge strategy. Like that. And we have no changes, okay. And we are still in the merge. So what we have to do now is we have to go to stats RS and we have to add the same changes there. And that means when we say counter.add, we have to say only update. So where is that? Samples? We don't have the comment, the same comment, because there's a counters comment above. Maybe. Let's add that here, counters. Oh, and we do have a true in there. Okay, so instead of true, we have to say self.hasSampling. And let's also add the same comment. Only update, what does the comment say? Only update timestamp when sampling is enabled, as this has performance impact. Okay. Makes sense, that comment. And that was it. That was the whole commit. So let's commit this. So adding everything. Quick checking diff. Diff says this. Yep. Okay. Hit commit. Next one is done. By the way, what did the test say? Oh, they're not there anymore. Okay. Next one, next commit. Next commit. Changing. Okay, what is that? Changing use of map to unordered map, since we don't need ordering and it was impacting performance. So there's a change from map to unordered map, also in stats, and that is the entries. So let's see how we did it in Rust. Entries. So we already are using an unordered map.
So this next song is called Blame Me.
Yeah, we are already using an unordered map.
This one's pretty self-explanatory. It's basically about
right?
when you come to the end of a relationship and you know it's not working out, but it just
so that means we don't have to do anything. That's cool.
So this is just me.
So we can just
I'll be the bad guy.
merge this commit.
We can go our separate ways if that's what's going to be easiest. Let's do it.
LF says blazing through these commits. Oh, I'm too fast. I can also go slower. Yeah, let's merge that one. And we don't have to do anything. This means no changes. Yeah, so let's commit that. And if we now have a look in the graphical Git tool, this looks really funny now. I like this manual merges, like commit after commit after commit. Also, let's enable dark mode. Where can I make this dark? Oh, my system isn't dark. Oh, it is dark. Yeah, so we now see, okay, this will look funnier when we are done. So we will have a lot of those merge lines here. LFLF says, no, it's great that you can get these done so quickly. Yeah, I'm used to this now because I have to resolve merge conflicts now every time the core team makes a commit. So that one is done. Oh, and by the way, I wanted to do this in every stream now, like just check what the current translation progress is. So let's run %rust. And what does it say? It says 40 point, oh, can you see it? It's a bit small, 40.49%. Vivex says, this is why I work alone. Yeah, then you don't have merge conflicts. That's yeah, that's on the upside, yeah. And Defnal says, at least it's not just a few huge commits. Yeah, that's a pain. Like these small commits, they are easy to merge. Like even like, and I'm a huge fan of small commits. So see what Colin did here. He made the small improvement and it made it one commit. And that's just super simple now for me. Imagine he had done like many changes and then produced like a gigantic commit. And I would have to merge that. Oh, that would be horrible. So Yeah, hooray for small commits. So the next one, what does he do here? He changes also a map into an ordered map. But this time it is... wasn't this the same? Only... Oh no, wrong commit. This one is the next one. One commit, Rust rewrite, says VMAX. Yeah. I can squash all my 1000 whatever commits. How many commits does Ars Nano have? Let's see. We are what? We are 1933 commits ahead. Imagine like squashing 1933 commits into just one commit. And then I create a pull request. Yeah, that's the plan. Okay, so which one? Add toString functions to the classes ask pull request and okay, that is from who made that? It's a pull request from Brandon BB. Is that a new contributor? Who is Brandon BB? Let me just... Can I check the pull request? I'm curious. Add toString functions to the classes ask pull request, ask pull acknowledge. Okay. Cool to see like new... Or maybe he isn't new, but I don't recognize the name. Cool to see like more names showing up here. So what did he do? He added a toString function to a sending pull request message and a sending pull acknowledge message. Okay. Yeah, that's also a small commit. Lovely. I like it. These things can be ported quickly. So toString ask pull request. So let's go to our Rust code. And let's merge. No, let's first merge this one. So git merge. Where are the changes? They are in messages CPP. So again, I say this merge strategy is ours. And the commit is this one. Oops, ours. I forgot to say no commit. Let's redo this. And no commit. Okay, I'm already in the commit. And now let's go to the file. Is it messages RS? I don't know. Here. And let's go to ascending pull request. So this is the message, ascending pull request. This was introduced when the core team added the ascending bootstrap, which would pull blocks from the oldest one to the newest one. And so like in the correct order, like they happened. And this speeds up bootstrapping enormously. So, and for that there's this ascending pull request message. And let's see, do we have a toString for that? No, we don't. So I also would love to have a unit test for this. It's a shame that there is no test for that in the original commit, but maybe we will add one here. So there's no toString for ascending pull request. Let's implement this. And in Rust, we don't add a toString method. We make use of the display trait. So we will just import display for ascending pull request. And this will give us a two-string method automatically. So, and let's also add a test here. And we call this, oh, let's add it at the bottom. Let's call this, yeah, just display. And for now, I will just make a failing test that says whenever we have a pull request, like up here, and so let's copy this first, and then later we introduce helper functions, because I don't like code duplication, even in the tests. And I learned this from James Shore. He says that each data structure in his code has a function called create test instance, and that just fills it with test data. And if you have that, you can just very quickly write tests. You can just call create test instance for everything, and you don't blow up your code with these duplications. So this is something I want to do for the ascending pull request too. But now to get started, let's just keep it. Let's just duplicate it here, and then we remove the duplication. So let's call this request, and then we say assert request to string is equal to do. So this should fail. Let's run it. CD Rust, CD Node, run tests. Compiler error. Oh, because I have not implemented the format correctly. It has to return a result. So let's how does it work? I haven't right like this, I think. Like let's add some dummy data here. And now let's run the test. And now the test should fail. It should say expected is to do, but actual was this garbage here. And ooh, runtime. Oh, this is because I'm now. Oh, okay, maybe I can. This error here comes from me not running the tests after doing the last refactorings, I think. This function should return a result or option to accept. What? Where? Ah, okay, so there's the question mark operator. So this is fixed. But the other problem isn't fixed. The other problem comes from my refactorings I did earlier today or yesterday. It says there is no runtime found in Tokyo. So I think this is just I have to add the runtime stuff to the cargo toml. Let's go to node and let's have a look at the cargo toml. So this is where we define all the dependencies, the library dependencies that we use. No, that is not the problem because here we have runtime and everything in it. Let's have a look at the error again. It is in mod rs transport. So let's go there. So there, and which line was it? It was line 116. Why is this a problem here? Runtime. Do I have to enable more feature flags for runtime? Do I have to add more features? Let's search for the documentation. Tokyo runtime. So it requires the create feature RT, and I have that in the node, don't I? There's Tokyo, and it has the feature RT. So why doesn't it find the runtime? That doesn't make sense. Chat, do you have any ideas? What could be the issue here? It is in here. It says... No, sorry, wrong file. Transport mod rs. It says... Doesn't find the Tokyo runtime. Or it doesn't find the new function? Is there no new function? There is a new function. Here it is. Creates a new runtime. Or is it now called... Oh, what test is this? Create test instance with channel ID. Maybe I don't have to call new, but... Let's have a look at the documentation. How to create a Tokyo runtime. LS says maybe you have to import a trait to access the new function. That's a good idea. Ah, okay, here it is. I found the problem. The new function is only available in RT multi-thread. Okay. RT multi-thread. Yeah, okay, then let's just add that to cargo toml. RT. Is RT multi-thread? Yeah, okay, let's add that. Because we do want to have a multi-threaded Tokyo runtime anyways. So, but now I think it has to recompile a lot. Let's see. Okay, we got it. That was weird. Okay, so we got it. Finally a failing test. And the failing test says exactly what we expected it to say. It says expected this to do, but actually was garbage. So I want to keep this test and like that, and now I want to bring all of the changes from the upstream commit, and then in the end I I want to just adjust the test to pass. So let's start writing that one. The correct implementation of toString. So let's go to commit. What does it do? First, it writes the header. So let's do that. We write the header. There's no header? Self header. There's a header. What is self? Ask pull request. It has a header. Here it is. Oh, do I have to do it like that? Yeah. And now we have the header. And oh, right. Can we say right line? Yeah. So that adds the new line. And what happens here then? Visit. Ooh, what does this do? Okay, it is if const expr is same empty payload. So now it checks the payload, and depending on the payload type, it adds different things here. So let's do the same here with the empty payload. So we can do the same thing in Rust with match self dot payload, and we have invalid blocks and account info. So empty payload. Is invalid the same as empty? Just checking. Invalid blocks. Yeah, I think so. Okay, so invalid. When it's invalid, we write. What do we write then? Missing payload. Okay, just missing payload. And no new line, no nothing. So let's write missing payload. And oh, F. We have to say write to F. And blocks. When it's blocks, then we say okay, we write multiple things then. So we say write line. What does it say? It says account. And then we add the start. Log dot start. Start is hash or account. String. And the next line. Oh no, it's not a line. It's not a line, it's just writing it like that. Oh, sorry guys. Like that. Ooh, wrong. Okay. Account is start. Then we add max block count. Oh, let's just add it all in one line. Why not? Max block count. What is the max block count? 2 string hex. Arc count. So this is formatted as hexagon. What's hexadecimal string? So 2 string hex. Do we have something like this? I think we have. Hex. To hex string. 2 hex string. Has a 16 with 16 bytes. Is that right? And 0 prepended. I'm just thinking, why is it printed as hex string? Why? This is just the max block count. Why should this be a hex string and not just a decimal string? And it is U8, just a byte. So the max value is 255. You know what? So I know these strings are just being used for debugging or logging. I don't want to print it as a hex string. I'm just printing it as a decimal string. And the last thing is hash type. Hash type. Hash type. And hash type is 2 string hex. Start type. Hash type is start type. What is start type? Blocks, that's start type. What is start type? Start type is a hash type. What is hash type? Okay, so this is either 0 or 1. So it does not make sense to use hex notation for that one either. So I'm just say as U8 to print it as a number and not as a name. Okay. And the last one is account info. And what does info have? Info has just target. And target is arc.target to string. So arc.target is info.target. And what else? Hash type. Hash type. Ooh. And hash type is arc type. So that is info dot target type. Is that target type? Hash type, target type, yeah. So what is target type? Target type is hash type again. Hash type is block or it is account, so it's 0 or 1. So this also doesn't make sense to print it as hex. Okay. I think that's it. Let's run the test. And the test says, ooh, is that expected? So so as you can see here, so this is now the message written as string, and the first part is the header, and that is up until here, and that's okay. So it adds a new line there. Then it says target, and there's this thing which is okay. It's a hash, and then it says hash type 1. So let me just copy that and put it into the test because this looks good. Oh, no. That. Oh. Is that okay? Let's run the test. Antiphon says, this is so much more interesting than the last stream. Yeah, that's not hard. The last stream was really, really boring, and I promise you I will not ever, ever, ever search for bugs in the stream ever again. And, you know, guys, stream, so I really wish that I can get all of this stuff to Rust soon, because this, what I'm doing here, I don't find it particularly interesting. The really interesting work is the refactoring and the unit testing. And this is just stuff that I can't do very often because I'm just very busy with all of this basic stuff, like bringing commits over, or even porting code from C++ to Rust. That's also that's not really the thing that is super interesting, because we're just taking code in one form and we bring it into another form. But the refactoring is the really interesting stuff, and I hope that we can go to the interesting stuff in the future, or soon in the future, and we don't have to do that kind of work here. So yeah, the test passed. So let's also add test cases for the other two payload types. So this is display. This is the account info payload. Then we have what is the other payload? Request account info. So we say request blocks, and here we have to say block request payload, and we have to give a start. What is this? Hash or account. So we say count 2 start type. What was that start type again? Hash type. So let's oh, there's also unwrap. Yeah. Oh. Let's run that test. Oh, so Still something wrong. Expected comma? Oh. Count. Okay. And and this should not be called display account, info payload. This is block payload. Okay, let's run the tests. And what does the string look like? Message type, extensions, and it says account, max block count 2, hash type 1. Looks good to me. Let's copy it. And let's put it into the test. And now the test should be green. Yep. And also let's add a test case for the last one, which display invalid payload. And here we just call to string without setting a payload. And and let's see what this returns. Missing payload. Yeah, copy that. And let's put it here. Good. Okay. So I'm just thinking whether I should... No. So just to let you know my thinking process here. So normally I would create helper methods for this type here. Like I would want to say, okay, no, let's do this. Let's do this now. But I want to commit first because I want to separate the merge commits from refactoring commits. And then we create a small helper functions in the James Shore style with the create test instance naming. So the test should be green. Yeah. So let's reformat the code. Oh, yeah, wrong folder. Let's reformat the code. Let's commit this merge and then let's introduce helper functions for the test data. So here we have the toString implementation and we have test cases, and that was all. Oh no, we are not done. This was just the ascending pull request, but we have the same for the ascending pull acknowledge message. Yeah, this, okay, we have to do that one first. So ascending pull acknowledge. Oops. Key press. Ascending pull acknowledge. Okay. Oh, okay. I want to just do a nano giveaway quickly. Let's go to our random number generator. A number between 1 and 4. 1, 2, 3. Let's click it, and the number is 4. So congratulations to Underhafnal. You earned it. A One nano. Oh, password. So, okay. Okay, so we need to go to the acknowledged message here. And we have to implement display for this one too. So import display for ask or pack. Come on. No code actions. Okay, I have to say which display, the format display. Yeah, now it worked. And let's also add a test case. Display. And we create a message like up here. And then we say after that original string is equal to to do. Let's okay, this has to unwrap here instead of question mark. And let's also rename this to pack. And let's see if the test fails. And it should. It failed with an empty string. So let's have a look at what the commit did. So in the same way, it just rendered the header. So we say write line self header. And then the next thing it does is, again, matching the payload type. Looks very similar. So we can just say match self dot payload. And in the invalid case, we say write missing, what was it? Missing payload. In the blocks case, we say what does it do? Block start, block end. What? It writes the whole block as JSON? Who? That could be a huge message. Blocks dot blocks, but let's iterate as references. So we just write it as JSON. So we say write we say write, and now we have to convert it to JSON. How can I do that? To JSON, it returns a result string and error. But it cannot convert format error. What? It couldn't convert to error. The error to format error? Question mark. Yeah. So we have to say map error. We have to map this into... What is the error type of format result? Struct error. What is this struct? It's just an empty struct. Doesn't have anything. Okay then. We can do that. That. And this we don't need, so this can be an underscore. Okay. We are actually writing the whole block as JSON. Crazy. And that's it. So in the account info case, what do we do here? We say account public key. Account public key. And it's info account to account. So this is info.account. Account is how it's called here in RS Nano. So what encode account is it instead of just writing it as a hex value, it writes the value as nano underscore and the encoded account. So like the usual nano addresses. And then we have an account open. And account open is account open. Info dot account open. Then we have account head. Info dot account head. LFLF says the Rust match statement is so much more readable compared to the const explorer. It's crazy. Yeah, I feel the same. The match statements are a lot more readable than that. Block count. Block count. So we're adding the info dot block count. Okay, this adds the block count as hex string. Does that make sense here? I don't want to hex. I want to have it as hex strings. Confirmation frontier. Count conf frontier. And what's the last one? Confirmation height. Confirmation height. So that's it. And the hit height is also hex string. I wonder why. Let's just go to the pull request, and I want to see if there's comments about why this is written as hex strings. No. There's no... No, okay. Okay. So let's run the test. Does it look good? Account public key. So here you can see this is the account public key now. Nano underscore. And oh, you can't see. Well, there's my camera picture in the way. Let's move it up. So that this is like encode account writes it in this form. Nano underscore. And so on and so on. Account open. Otherwise it would write it like that, just as a long hex string. Yeah, let's copy that. Looks good. Oh. Copy. And this should make the test pass now. And I won't write test for the thing with the block, because I don't want to paste the block chase and stuff in here. Okay, so but we are done. This commit is ported to Rust, so let's commit this. Let's reformat the code, and add Rust. One last check. Yeah. Commit. We are done with that one. So now, like when we push up to my GitHub, we should see the number go down of commits that we are behind. So it says 17th commit behind, and it was 20 or 21? 21, I think. So yeah, chat. So this is how I stay up to date with what Upstream does. So what's the next one here? Just want to see. There's... What is this? Oh? What? No. Oh, this is the merge pull request. So these are the changes we have already committed. Okay, so this is just the merge commit for the pull request. So this we can just bring into our code base without making any changes. So let's just copy this commit ID, and let's say git merge hours. And this should make no changes. Yeah. Push. Okay. Now this was fast. Now we are 19 or 18 commits behind. 17 commits behind. Is that correct? 16 commits behind. So the next one is from Colin. Update boost submodule to 1.82, which fixes a deprecation warning for sprintf on macOS. This we should be able to just merge without any conflicts. Let's try. Copy. Hit merge. Did it do anything? Yeah, it did. Submodule boost. Okay. So what's more on upstream? Okay, this looks like it will get a lot of merge conflicts. Rename, because renames are always problematic. Rename the class nanoscheduler buckets to nanoscheduler priority. Naming it priority scheduler matches the naming of other scheduler strategies like hinted scheduler and optimistic scheduler. And it does a rename, but I think I'm lucky because the scheduler stuff, I think I have not ported anything of the schedulers. Oh no, that's not right. I did port stuff from the schedulers. Oh my god, look at all of those changes. I'm not starting that now because it's late already. Nope, no way. Maybe we can just like have a quick look at the other commits. Add checking delay within gap bootstrap to fix. What is this one? Oh, okay, yeah, I remember. This one is fixing a unit test that fails from time to time. The block is not guaranteed to be broadcast to both other nodes after it is generated with send action. Okay, so this fixes a unit test. And more renaming here. And fix active transactions completion type. Yeah, there's still some things. Okay, so this will be my work for the next days. Bringing everything like up to date again, merging all of those commits here. And if not as well, it was fun while it lasted. Yeah. Yeah. Oh, yeah. And if not, I hope so much that I can start a refactoring stream soon, because that is like the real fun stuff where we can discuss how the code can be cleaned up, how the design could be improved, how the testability can be improved. But before we do that, I really want to get this async stuff to run in Tokyo. And that's just like the difficult and boring part where I have to go bug hunting, and finding those bugs can be a tedious task, can take forever. But once the Tokyo stuff runs, maybe we can refactor the networking code and make it use the real async, the real Tokyo async stuff, instead of going through the wrapper I'm using now. That would be really cool. So yeah, let's do one more Nano giveaway, and let's call this a day. So at least today you saw how I keep up to date with what's happening in upstream. Okay, let's pick a random number. 1, 2, 3, click. The random number is 3, so that is, let's go to the address as text. LF. Let's send you one. Nano. There you go. LF says, looking forward to the refactor streams. Yeah, me too. Because there's so much interesting stuff I would love to show you. But we just have to do this hard work first. Nano is the light, says Andef now. I have to go to sleep. Yeah, me too. Guys, it was fun as always. See you next Tuesday. And I really hope that next Tuesday I can say that Tokyo is running. and that I have a better node running in Tokyo. That would be so cool. So I'm giving my best to find the issue, and I'll let you know on Twitter and on Discord. So for all the new viewers and all the new viewers, rsnano.com is the website, and there you can find links to everything, to our Discord, to the YouTube channel, and so on, and to the source code. And yeah, just oh, we have more viewers now. Post your Nano addresses, and I will do one more Nano giveaway, guys. I see 7 viewers right now, so post your Nano addresses and you get one Nano. Yeah, this is so exciting with Tokyo. Like I'm really looking forward to having the node run in Tokyo. And that's just an amazing switch. That is really like switching out the engines of a flying plane. It really is like dumping one runtime, async runtime from C++ and then just going to Tokyo runtime. That's a really big change. And if that works out, then everything else will be a lot simpler. Okay, so no new Nano addresses. Okay, so let's just do one more. Lucky number is 2, and that is Wenderson. Nano is the light. Nano is the light. Okay. There you go. Yeah, it was fun, guys. See you next Tuesday, same time, 7:30 UTC. Good night. Bye.